anything installed for that right now. So, all right, but at least we have slightly more readable code. So first, at the top here of the shader, you have a definition called shader type. I'm going to show that in Godot because it may confuse some of you, and then we'll jump into Emacs to edit the shader, have a little more visibility on the screen, and so that I can fold that completely and just focus on the shader itself. So at the top of a shader, the first line is a definition that defines its type. So there are a few. Canvas item is for all canvas item type of nodes. That is all the 2D nodes. And yeah, it's for 2D shaders. Then you have a list of variables that start with the uniform keyword. These are the equivalent of exported variables from GDScript. So if I open my material in the inspector, on the right, you will see it has a list of shader parameters, and these are all the uniforms we've defined in the shader. So Baastian had defined most of them. I just added some parameters for the waves to combine two waves. Let me show you the base project, by the way. So this one is a little bug because I just moved the resources for the stream. There we go. So it starts with very simple waves here on the water sign material. Are a little bit small, so let's set the amplitude to something okay, too big. So you'll see with shaders they can be very, very finicky, so be wary of that. Don't be too afraid if things are strange. So 0.1 is too much. Did I go 0.05 before? 0.05 is not that strong. 0.1 is too much. Okay. So there you go. We have some sign-based waves. So these are mathematical deformation of the texture using a periodic function. I'm going to open Desmos to show you that. It's one of the few cases where it's quite useful. So let's see if we where's the pop chat? Want all these watercolor shortcuts. Hey everyone, thanks for joining. So for the waves, it's using a cosine and a sine wave in that case. So we're using this periodic function here to over time animate the height of every pixel in a sense. It's a little complicated to explain. We'll do that in a proper tutorial. Take the time to help you visualize this, but I'm going to multiply the time factor, so 0.6 and 1. So it goes a little faster. Okay, so you can see the height of the texture is being animated, and it's being animated per pixel in this case. And that using these adjusted UVs. So the way I don't want to make a full tutorial at this point because it's going to be a lot of experimentation, and I'm not extremely comfortable with Godot's shaders yet, but the general idea is that you use a set of coordinates to sample pixels from your texture, and when you want to animate these with a shader is a program that runs per vertex on your meshes. So you can see that on the little Godot. Every 2D element by default has 4 vertices, one in each corner. And this is an example of animating these vertices. Here we are animating the pixels though. So the shader will run once per vertex and then once per pixel in your texture. And there's always a difference between the texture's resolution, how can I say, the raw image and the image that gets displayed on screen. So the shader has for each has for each pixel on the screen to go see your texture. This one is fairly small, by the way, and it's going to try to sample the right pixel on the texture. So by default, it tries to map the texture directly, like stretch it onto your rectangle on the screen. That's what happens if I go back to the shader and I change the tile factor to 1. You can see that precisely here. So it's in this case, it's trying to preserve the ratio of the texture, and it scales it so that it maps the entire rectangle. But the shader is still like making calculations for each pixel on the screen. So even though the picture looks blurry, it is maybe 1000 times 500 pixels in this case. All right, so to do that, it's using two coordinates called U and V that allow you to map from the source texture to the screen. So it's going to, how can I say, for each pixel, it's going to tell the graphics card which pixel it has to use from the source texture and where it has to place it on the final rendering on the screen. So when you want to modify and animate the texture with a shader, you're going to animate these two coordinates, and you're going to shift them based on functions, on time, on the position inside our rectangle, for example. That's what we are doing here. So we are offsetting the, how can I say, the place where the shader is going to sample from the source texture using this function. So we are modifying the height for the y-axis. For example, it's using a sine to be exact in this case. All right, it's using this function, and based on the coordinates inside the bounding rectangle, it's going to, as it moves along the rows of pixels in your rectangle, it's going to go fetch pixels a little more up and a little more down gradually, giving you this wave effect. And so in the second example, you'll see that in the final tutorial, we will break these down a lot more step by step, but the second example uses a texture for that. So instead of using mathematical functions, it uses the pixels from a texture that it interprets as UV coordinates to shift where it's going to sample pixels from the source texture, and this gets animated over time. So the way it works often is this texture you can see in the bottom right corner of the screen. We animate it like panning and repeating itself over the source texture, and then as it pans, we use the pixels mapped on our water in this case to shift the coordinates on the original source texture that we sample. If I go to the, I shouldn't change this shader, but if I go to the shader inside of it, and here I'm going to duplicate the last line, which is calculates the color that gets rendered on screen. And I'm going to show you, not this, we're going to show our DU, DV, UV, wait. DU, DV, UV, okay, vector 4. DU, DV, UV with another vector 2, 1.0, 0.0, Yeah. Wait a second. Does it work with this definition? No, it doesn't. Like DU, DV, UV. What's your content? So let's use the DU, DV, UV map. Ah, it's already a vector 4, right? Let's. Vector 4 are colors. It's a sampler here. DV, DU. Wait, Vector 2. Where do we use you? Ah, my offset is here. Okay, okay. I messed up. That was not the right variable. So DUDV. It's a bit of a pain to work with this shader editor, to be fair. Okay, so DV offset. Okay, I'm going to use the offset. Wow, is it that small? And let's divide it by UDV amplitude again. All right, finally we can see it. So you can see our texture, offset texture mapped here. Let's see with the, so the hard part with shaders is visualization when you don't have a visual shader editing system like the one that was in Godot 2. This one is probably coming back sooner or later, and that'll be very cool because we'll be able to see. Normally when you have a visual shader editor, it allows you to see at each step for the equivalent of every line of code here, let's say, to visualize how the image gets transformed. So let's, but if you are writing pure code, you have to do these visualizations. You have to add lines on your own. Okay. Normally, the adjusted UVs use the offset. Okay, I can just multiply it by tile factor, and that should be good. Wow. How come? That seems a little strange to me. Times aspect ratio. Do I have to multiply this? Our offset takes the UDV map and the UDV UV. It's not a correct visualization of my texture, but I'm trying to show you the panning texture that we use to deform our water here. It's not coming too well. I'll work with the final shader. I'll show you that with the final shader. So then we have the same shader, but using a light 2D. So when you make shaders that deform your texture, at no cost, you can add the light 2D node to add light on top of your water, whatever you make, a rock shader, I don't know. And it takes in account the normal map on your texture. So you can create nice bumpy walls or things like these here. Now, this normal map doesn't fit the water too well, but it gives you an idea of the effect. And finally, we have this shader that's a little more jiggly and all. That's the one I was working on right before the stream. This one is using the sine wave and the final deformation texture in the shader to calculate some shadows and add them using that shadow color so we can update it in real time. And you could probably make it global somehow and update it in your entire game in real time. So let's see if we have any messages. Hey Gilles, hey everyone. What graphics card do I use? Really? It's NVIDIA Quadro in this computer. I don't know the model. I have a Cintiq Pro Wacom Mobile Studio computer. So it comes with professional graphics cards for computer graphics, visualization, things like these. But to be fair, it's not the best card for games. Normally, it's better for things like it works well if you want to do video encoding, all kinds of 3D rendering, like computer-assisted drawing, things like these. Normally, 3D programs and all are supposed to be optimized for these types of cards. Okay, so let's work on this shader. We're going to do a bit of experimentation. So I'll leave the material here and I'm going to jump into Emacs. Whoa! Ah, nice! I have that new thing. I forgot about it. Ah, actually, that's really cool. That's really cool. So I have this thing that's recognizes different variables in my code, and that assigns them a different color so that you can see them a little clearer when you are working in your script. That's pretty fun. So I'm going to work with Emacs and the C language here. Even though you don't get the auto-completion from Godot, you can see that it's a little easier to see the code. There's one last thing I want to show you. Going into the shader, I'm going to bounce between the two editors anyway, because I don't know the shader language by heart, but one thing I want to show you is this. So this is the shadow mask here. This is the, how can I say, I call it the height of the shadow, where the height of the wave. So normally the white part represents the top of the wave and the black part represents the shadow. I hope I'm not messing up, or is this the opposite? Let's see if I just push my offset times G times 2.0. It's a little too violent. Okay. Yeah. All right, so when you're working on shaders, you want to come up with lines to... First, it's a little tough to work on shaders because you have to think mathematically and have an idea of, how can I say, you have to think with numbers and try to have an idea of, you know, how it will map on the screen, how it will translate into colors. So you have to manipulate these numbers to achieve, like, render certain things on the screen, and it's a highly experimental task. Actually, the people who focus on shaders in the game industry are typically called technical artists, because there are artists who can work with, like, code and abstract things and convert these, like, create images, create things from that. So other type of technical artists may involve people working with sound, like procedural audio effects in game, where they compute, like, create entire systems and graphs of the way the sound is going to work depending on where you use it, how it's going to react to walls, whatever. And yeah, shader artists do a lot of research and experimentation on as part of their work. So what are we going to do next? We have a little shader here, and one problem I had with it was the number of parameters. I think there's a little too many in this. Tile factor, aspect ratio. I want to remove the aspect ratio for one. So let's start with that. I'm going to remove as many parameters as I can to simplify the shaders code at the moment. So UV offset scale. UV offset texture and wave size. This is for, so to make a convincing water, how can I say, water animates based on, like real water has multiple levels of frequency and waves based on the forces that produce these waves. So they add up together and create, how can I say, edges and softer waves and all that stuff. And to recreate that in a game, you need to combine often multiple textures together or multiple levels of waves. So right now we have two. We have one here called we have the sine based wave. I shouldn't have called the parameters like this, but these are the line 29 and 30 in this case, where it uses math functions to create these big rolls. The larger effect on the waves come from that. And then you have a high frequency effect with the texture based offset. And this one, the advantage is that you can plug in and replace a texture anytime. So right now, I think it's a noise texture, and it's going to add some high frequency details. To give you an idea, if I was to set the texture based offset to 0, you will see a subtle difference. Let's see if it works if I do that. Can we see the difference at all? But maybe, yeah, I recalculated. I've got to clean that up. Okay, let's do that. So, all right. Remove the aspect rate. Oh, it doesn't. Wow, Godot doesn't reload. Wait, why was that? Why is there an aspect ratio here? Wait. What is that? Sorry, there's something I don't quite understand. So this is adjusted UV here. Okay. Vector 4. We're going to create a new color, the adjusted UV, and another vector 2, 0, 1. Let's see, let's try to visualize you, my friend. Forgot the semicolon. Why do we have this aspect ratio? Right, let's remove the tile factor as well. Then we have to. Okay, someone's coming home. Okay, let me see. Why did we have that aspect ratio value? Should it come from... What's your size, my friend? Whoa. Why is it scaled? Sorry. Yeah. It is scaled because it should be scaled. It's no 2D. I see, the texture stretches, and so it doesn't use the scale from the... Okay. Got it. So right now, yeah, the aspect ratio is necessary, but I was wondering why there was this hard-coded aspect ratio. It turns out we need that variable, but wait, let's go back. I can't go back. So let's go back here. Okay, we need to multiply you by aspect ratio, and we are good. Let's look at the chat real quick. Maybe you can change the import properties of the texture. Yeah, I work a lot, actually. So this morning I worked, then I went hiking, and yeah, back here to work a little more. Now the aspect ratio is a hard-coded value at the moment. It shouldn't be. So the aspect ratio is a multiplier we use so we don't get this ugly stretch effect, so that the texture fits the rectangle a little better, and we try to preserve the texture's aspect ratio when applying it. Now, Gilles said you should check the import properties. So to be fair, it's not going to be an outstanding stream, but I don't think repeats is enabled for everything at the moment. Yeah, there's no real property I can use here, I think, to fix this aspect ratio thing. We need that value to multiply, like to map the texture and tile it on the node. Is it because we use a sprite node? Well, with a texture rectangle node, you don't have the issue, but with a texture rectangle, you cannot use the light 2D system because it only interacts with 2D items. So if you need a tiling texture like this one thing you can do is calculate these values from GDScript, use a tool script so that when you resize, when you change the scale of the texture, the tiling and the aspect ratio values update automatically. But we're not going to look at that right now. I've got some work to do on the shaders. For now, I'll leave the aspect ratio kind of hard-coded. And so people are wondering where there's maybe a built-in shader variable. Yeah, if you can take a look, Jill, that'd be really great. Thank you. I don't know, I don't know all the functions and all that stuff yet. It's been a long time, like 6-7 years ago, I wrote some CG code and HLSL, but it's two shading languages. So for people asking about the language, this is a Godot shader language. So it's specific to Godot, but it's very close to GLSL. But shader languages are just close to C. They just look like C. All right, so let's see what we can work on right now. Oh, I have to add our aspect ratio back. Where is it? Down there. All right, so let's see. We use the texture-based offsets. I'm going to try to just simplify the shader a little bit, like the row code, make it slightly easier to read. So tile factor, aspect ratio, okay. UV offset texture, UV offset scale, wave size. Wave size should change, I think. Oh, let's go. Grab you. Wave size. Ah, no, it's not going to work. Wait. Let's do it like that. I'm using it in a few places. All right. The wave size we're going to replace you with. I think it's texture offset size or scale, because I'm multiplying it right there. Okay. Okay, so UV offset texture. I don't know how to name these variables so that they are not too big, but that they make sense and they are not too big. UV offset scale, I think. UV offset scale. Texture offset scale. So I know that these are the texture based values. Let me see. We're going to change you for a floating point value to simplify you. Yeah, but I was using different values for that, right? Shaders are often a little complex in nature. It's often a bit hard to modify them. So timescale, single value. Am I using it? Oh, I have a separate timescale for the sign. Okay, so base UV offset. Why do we use the base UV offset for the height as well? So right now I'm just doing some refactoring. Okay, we are good here. Sine wave size. So one thing I have to change is the water height. The water height is recalculating a value that we already have above. So it's using adjusted UV.x. Okay, so float wave height. Hold on, let me see. What did I do? I think, yeah, that's from here. It's not the same actually. Float sine wave height. Okay. Okay, sine wave height. And texture. So we think we calculate that twice, right? Okay. Offset texture UV. Let's do that. Okay. 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 All right. Should do the trick. You reload, Godot. What did I do? Texture offset scale. Am I wrong? Did I add a value? Texture offset timescale. No, it's here. Whoa, Godot doesn't reload shaders. So the editor is not the same as and because I'm using C and Emacs, it's not using tabs. Tabify. Okay, save. Doesn't reload. Save here. Loads here normally. No, it does not. Come on. Okay. Now I can tabify. Save, but it doesn't reload here. Ah! I'll have to find why that is. I messed up when I renamed the things. Offset texture UV. So times equal wave size. Texture offset. Texture offset height. Okay, are we good now? Yes, works again. All right. Let's see the chat. How do shaders affect the performances? Are they good on a mobile device? So, very good question. A little tough to answer, but it depends a lot on the graphics card, or as you might expect. The thing with shaders is you really have to test, because this program, the fragment program, is run once for each pixel inside of your texture, and so the effect on performances depends entirely on the size of your shaders of these programs and on the size of these textures on the screen. We are talking about screen pixels. For example, if I'm zooming out like that, this shader may be very complex. It only fills a small square on my screen, so it will not affect performances a lot globally. If I have a super complex shader like that that takes the entire screen, every single pixel here is going to call this entire program. It's going to run through all these instructions. So then, if you have performance issues with shaders, you have to find ways to optimize them. So you have to find tricks to make them work. In the past, memory, like when I did that, memory was very important. So we use tricks like we mix textures. For example, here this texture only uses the red and green channels, but back when I did it, like we would use tricks to recalculate one channel from another, so we would have essentially 3 textures in a single image, 1 per channel. We use that a lot, because if you load 1 texture in memory, you have 3 channels worth of data, but if you load 3 textures in memory, you use 9 channels, even if they are grayscale, right? So you use 3 times the memory for just 3 pictures. Today, it's not a problem, and on mobile devices, on some older mobile devices, it can be an issue because they have maybe limited memory, but it's not your biggest problem. If you are making 2D games on desktop, it likely won't be a problem. What happens often is, like for people who have ultrabooks or these very cheap computers, you need an option to deactivate shaders globally in your game or something like that, like some rendering settings, and you're fine. And then you can go a little crazy with your shaders. But again, that's the kind of thing. When you do shaders, first make them look good. And once you have the result that you want visually, then you start to think about performances. And because once you have the final result, you know which techniques you use to achieve that result, which techniques are important, and then you can look at the functions you call, etc., and see if you can move some calculations to the vertex shader, because there are very few vertices, but there are lots of pixels on your screen. You can think about replacing some functions with others. So, for example, calling the power function can be a bit expensive. So that's one thing you can remove, push out of your shaders, things like these. But you have to see in context. Thanks for the question. Will we see real-time ray tracing in Godot as well? So real-time ray tracing is like it's existed for a little while, but it's not real-time as in like it's real-time with a supercomputer with something that no one can buy, like a $1 million computer. So there's no real-time ray tracing you can have like at home in a game or something like that. I've noted like you're not the first person to ask for that after seeing the Unreal demo. This is for people who want to make movies and who want to have like for large companies that can afford really custom setups for rendering. They can have, you know, they can really take advantage of these kinds of processes and try to see how the movie looks as they are building it or something like that. Maybe a solution might be to draw the pixel independently from the node 2D position and size. It might be achieved using the world matrix input. Okay, I will avoid the world matrix for now and those things because it's going to be pretty hard. One big question: how do you debug a shader? Next generation of graphics card will have ray tracing, dedicated GPU. Maybe I don't, or something like this. Okay, I don't know for what price. Like how many tens of thousands? Now, so ray tracing is a very old technique, and real-time ray tracing itself is, I don't know, it was achieved a long time ago. In practice, it doesn't change like a lot of things for us game developers. Like the level of fidelity you can get with the PBR workflow is already pretty good. Okay, NVIDIA announced this. All right, good to know. How to debug shaders. So to debug shaders, the best thing you can have to me is to have node-based like visual editor. So like you had in Godot 2, and again, this should be coming back in Godot 3. Did it have preview for? I didn't have preview for all of the nodes. So let's look at Unreal's shader editor, and I've seen that Unity has a pretty convincing one now. So this is a little better. This is the one of the tools I used back in the day when I was working with the UDK. So this kind of editor is really cool as it allows you to see a preview in real time of your texture manipulations. So that's one good way to debug shaders. As the result is visual, you want to debug them visually. Now in Unreal 4, yeah, they have a visualization where it makes sense to have it, and you don't have it where it's maybe a bit less necessary. But the idea is with these kinds of systems, you can try to plug your value in. I don't know exactly how this one works, but try to plug the value in the color of your texture that you can visualize in the corner of the screen. So when you are working in Godot 3 for now, the thing you'll do is you will add a new line at the end or anywhere where you assign a different value to the color slot. So for example, if I want to visualize my sine wave's height, I'm going to plug it in here, sine wave height. And the way I do it, I use a vector 3. So my sine wave height is a floating point value. So it's not a color. So I cast it to vector 3. So it's going to create an RGB color, base color, with the same value in the R, G, and B channels. So it's going to create a grayscale color, grayscale image. And then I cast it to a vector 4 with an alpha value, transparency value, opacity value of 1.0, which means fully opaque. So this allows me to visualize the wave, in this case, that's generated mathematically. Now, I use that to... so I have a fellow housemate here. I'm not going to keep the stream for very long, I think, to not disturb anyone, because people are coming back from work slowly from now. So, you can see the final result, but as I toggle this line on and off, I'm able to visualize the height of the wave. So I'm really trying to look at the height here. To be fair, it's a little hacky again. I'm not using the... am I using the height exactly? Yeah, I have the shadow. I have to think about that. The big issue when you are working this way to have a correct representation of the parameters that you create. And for that, you have to think, and you have to think a little hard. Let me see, by the way, sine wave plus offset texture uv.g. Why is it so weak? Maybe because I changed the parameter names. So, okay. Now they are reset to 0. Okay. So I have to change that. Let me see. Go back to the shader, the material, modify some of the parameters here. Texture offset height. Let's see, 1.0. Time scale 0.4, offset scale 1.0, 1.0. Do I get anything? I don't. Because it reset. Yeah, when you rename parameters, you also lose their value. So there was no texture in there. Now we're back with our good old offset. So let's lower the offset. Okay, this is really the offset scale. Yeah. All right. Time scale, slow it down. Now you can really see how the offset texture adds to the sine wave, how they combine together. Time scale should really be the speed of the offset. Now the offset scale should be something like different on the x and y axis. Let me see. What do we get? It's a little too strong on the Y. Yeah, but it's with a system like when you are working with pure text with shaders, it's a little hard to plug and unplug values into the final result and really focus on one part of the graph, as you've got to change lines. I wonder if this as fragment should be a function. So can I return from here, for example? The way to do it is to return anytime from the fragment function and add a color, like assigning the color you want to have to the built-in color parameter. This is your output color from the shader, and you toggle these lines on and off as you want to visualize a given value. For example, here I could visualize the adjusted UVs. I need a vector 2 and 1.0, 1.0, yeah, or 0.0. Doesn't work. Doesn't work if I do that. Let me see. Can't return early from the fragment shader. So return prevents the shader from running. Okay, so you have to add the line at the end. Right now, for example, we are visualizing the UV coordinates, so the coordinates that are used to sample the source texture image and to map it on the screen. You can look at the top left corner for the most part to get a sense of, how the green is the y-axis and the red is going to be the x-axis, and you can see that wave-like motion and also visualize it a little bit along the left and top edge of our rectangle. It gives you a sense for how it's the adjusted UVs, so it gives you a sense for how the sine and cosine are going to, how can I say, create these wave effects on top of the texture, as it's going to offset the entire texture up and down in this case. All right, we go back to the chat. Hey, Baastian. Will it be possible in the future to implement procedurally generated audio shaders, just like Shader Toy did? It wouldn't be, like, technically it's possible, but I mean, someone has to do it. I don't really know. I mean, Shader Toy is really a tool for demo makers, or to sharpen your map skills, or to, generate visuals and sound and everything procedurally. I don't think you'd see that in Godot anytime soon. I think the focus is going to be on the last few remaining core features, and then on the polishing the existing features. At least that's what one wants. So then it entirely depends on new contributors coming to work on things like these, do them well, So yeah, to debug your shader, you add a list of like color assignments at the end, and you toggle them on and off like that with Control K. It's interesting because the offset seems really weak when we look here. Okay. Now I can visualize the offset. Okay, I see now. Really interesting. The offset height. Actually, I don't visualize the offset height. Why is it? Yeah, because it's not being applied. Why do I apply it? Is it used anywhere? My texture offset height? Texture-based offset? And my texture-based offset, where is it? Adjusted UVs. It gets burned into the adjusted UVs. So one thing is, if you optimize the variable assignments as your shader, so I was talking about optimization first before, and if you optimize as you go, one problem is visualizing your value. If you break them down along the way, like you use lots of non-mutable values, the big advantage is that you can plug them into your final color and display them on the screen. One example is here. The offset height gets, like, it multiplies the texture-based offset value directly, so it mutates it. We create that value on line 24 and then we modify it on 25. But if we want to visualize that value, well, we can do it now, but if you wanted to visualize the base texture offset without the height effect applied, not, attenuated, you would have to redefine this value here, like assign it texture-based offset with height applied. It's a little verbose in this case, and then what's the matter? What did I do again? Times equal. So it's going to be equal to texture-based offset, texture-based offset times texture offset height. Then we look where we used that value before. Okay, we only used it here in the adjusted UVs. So now, because I've created a new variable that only stores the result of this calculation, I can go down to my color assignment and generate a new color from it. The only problem here is I'm trying to cast a vector 2 to a vector 3, so it's not going to work. So yeah, in shaders, you have a lot of manipulations of color channels. Okay, why do I get this result? Interesting. So by the way, the expert is Baastian. He's in the chat, so if you have really technical questions, you can ask him. He's got more experience with that than I do. Okay, and let's visualize the texture-based offsets itself. So with the height variable applied, it really scales it down that much. So you can see what I was talking about before. On the resulting texture, we really get that effect where we have, it's a little hard to see on the final waves, but we combine these mathematical calculations with this slight offset. And yeah, wow, it's scaled way too much. And we're really taking the UV offset texture and slowly panning it on the screen over time. And then we only apply our, like we scale it and we add it to the UV coordinates of our texture, like the sampling coordinates, to offset them a little bit. So the parts that are black, it's not going to add anything, so you're not going to see any offset. But the parts that are colored are going to displace the texture. And as this offset is panning, you get, how can I say? You get like the displacement moves along with the texture, giving it some rolling effects. This is how you get that wave-like effect. But right now, to be fair, the scale is a little weird. Texture offset is the scale here. Offset height, yeah, it's this one. And offset time scale. Let me see. Let's go back, visualize the final texture. Yeah, the problem is, so these offsets are often a little hard to visualize on their own because of how, like, a small value, a small UV offset gives you very strong effect, like a very strong result. All right. Well, anyway, for a test stream, it's not too bad, right? How late are you, Harry? I don't know. I don't have the time in the chat. Texture offset will be from -1 to 1. Okay, and you want to keep a small offset because your texture UV is normalized. A very small offset may translate to a lot of pixel offset in your lookup. I don't have a second screen. That's the problem. I can't keep the chat on the second screen. The black is where the offset has become negative. Okay, but did I forget the calculation? No, texture-based offset gets multiplied by 2 minus 1. Okay, I didn't check this line. So yeah, you'd have to create yet another variable. Like, actually, you'd have to apply the height before. If you want to visualize the colors of the offset, you have to swap these variables. So with height, let's see. is equal to offset texture UV times texture offset height, and texture based offset is going to be okay, offset texture height. Yeah, I'm going to swap these values, put you there, and now we should be able to visualize this texture. And but now I'm looking at the offset height. Is there a way to normalize colors? Yeah, I don't think that's a good idea though. Okay, so now we can visualize if I just pass in the raw texture, we can visualize it a lot better. So here's the deformation texture, the one that's going to add high frequency detail to the waves. And it's controlled by 3 parameters. We have a time scale that's going to like make it pan slower or faster. If I increase the value, it moves a lot faster, makes our waves a lot more jiggly, I guess. The offset height is going to scale, like it's going to attenuate the texture, so the colors, so it's going to make them a lot darker, meaning that the UV deformation will be a lot smaller. And finally, the texture offset scale is the texture scale in itself. So if I lower the value, it's not really the scale in that case. Messed up a little bit. Okay. So if I increase the value, it's going to... Okay, a value of 1 preserves the scale of the texture. How could we call that value then? Wonder. I guess I'm a little too tired for tonight. Okay, we're going to close the stream pretty soon. And I'll try to prepare a better one for next time. You can see the resulting water. You'll have a tutorial to cover that with a little more precision. The effect is still quite strong, right? Okay, thank you for joining. First stream in Japan, because finally there's not too much more noise next door. And what are the last few questions? I don't have a tablet. Yeah, pen tablets are not that expensive. You can find like Innova has decent tablets for not too expensive ones. You can also check the Hoyon brand. But okay, that's it. I'm a little too tired tonight anyway. So thank you for joining the stream. I don't know if I will keep it on the YouTube channel. This one, it's a little too experimental. But thank you all for joining. See you soon in a tutorial on the channel. Will there be a recording on the channel? Yes or no? I wonder this stream is not really high quality, so there will be tutorials dedicated to these shaders, and the sources will be available as well. So I think I will remove the recording from the live stream at the end, and you will have to wait for the shader tutorials to come out, if that's okay. Is this Godot engine capable of handling online multiplayer mode, IAP, and ads for Android? Online multiplayer, sure. AAPs and ads, yes, but it's not that simple to add at the moment, especially if you're a beginner. Like if you're an experienced developer, sure. If you are not, it's not that easy. All right, so thank you all for joining. And be creative, have fun. See you in the next tutorial on the next stream. Bye-bye.